Hi, this is Shyam again, and welcome to Machine Learning Made Easy with Mathematica 11, Part 3. In this video, I'm going to cover a couple of things. So let's start with the first thing on my list here. Let's start with what we call feature extraction. So feature extraction is experimental. It's new in Mathematica 11. So this is one of the first functions that we're going with that's new in Mathematica 11. And again, I say this because there's part 1 and 2. If you haven't watched those, check them out. They're in the links below, and they should pop up in a sidebar right around here. But yeah, let's get back here. So feature extraction, this is part 3. Feature extraction is new in Mathematica 11, so this is very, very cool stuff. I have a really good example to show you in that. And then the next thing I'm going to show you this today is 2 examples of feature extraction and a couple of built-in classifiers. So working with the function again called classify, and we're going to be doing some more stuff with this, see what's built in Mathematica 11. They've added some really cool stuff. So yeah, again, classify we went over in part 1. If you haven't watched that, again, in the links below. So yeah, that's what we're going to go over to this today, and let's get into it. Sure. So let's get into some feature extraction. So let me get some data set. Let me get this data set here. Boom. Who likes dogs? I do. Okay, so we have this data set, and then basically just like all of the other machine learning functions that Mathematica has, feature extraction is just like that. All you have to do is type in the function, the function, right? So classify, predict, in this case feature extraction, and then put in the data. Just like that, it extracts the features. So let me run that for a second here. It shouldn't take that long, but again, I've been running Mathematica for a while now, so yeah. So yeah, it just image and then length of extracted vector 20, impossible invertibility, and missing values forbidden. Again, there's a lot you can do. There's a lot of options you can put in after the comma, but again, we don't have time to do it right now, so I might go over it in another video. But for now, if you want them, again, F1, and you pull up the documentation, and then details and options, and there's plenty. You can do a lot with this. So that's there, and then what we're going to do here is we're going to use a function called nearest. And most of you should know this function, but if you don't worry, it's really simple. What nearest does, it basically applies a distance function, right? A distance function, and gives the nearest points to these feature extractions, right? So we're going to do nearest and get the nearest points to this feature extraction, and it's not the points, it's like the nearest dog almost. So what feature extraction is doing, almost, you can visualize this way, is it's taking all these dogs and almost giving them like a 2D point, right? An X and Y coordinate. And then what we're doing here is we're doing nearest, right? So we're seeing which of these dogs is like distance-wise nearest to the other one by X and Y coordinate, right? Just simple Pythagoras theorem, distance formula, right? So that's what we're doing here. We're applying nearest to it to get the nearest dog, almost. And that's what we're doing here when we create this data set. So let's do it real fast, and that should be great. We got this data set, and this data set, again, we got here, this is just nearest dog. So close that up. We're just taking the first of the nearest, right? So the nearest, we have a bunch of points and the distances to them, and then we're taking the first one from that, right? So the closest one first, and then that we've just created into like almost a function almost, right? So nearest dog, when you put a dog picture into it, you get the nearest dog picture, right? So let me just show you an example, right? Here we go. Let's try that. See what we get. Holy cow! This is a golden retriever, if I'm not mistaken. This is also a golden retriever. Mathematica was able to match these 2 pictures together. I can't find the first one. Was able to match these 2. Where's the first one? Not sure. I'm pretty sure you guys can see it and I'm not seeing it, but oh no, it's not in the data set. Yes, so one of the big things you want to know in Mathematica, machine learning in general, you never want to use an example, a test case, right? Again, if you don't know what a test case is, parts 1 and 2, sorry about this. You never want to test your test case which is in your data set, right? So your test case cannot be in your data set, or it just screws your data. Because imagine it, if we put this test case in here and it was in this data set, it would give us back this same dog, and we wouldn't know if it was accurate or not. So never have a test case in your data set. Okay, so it did it right? So it got it right that this dog looks pretty similar to this dog, and that's the beauty of Mathematica. In a couple of simple lines, you can do something really amazing. So let's look at something even cooler here. So with this, I'm gonna get some random data right here. Let's get some random data from the resource object MNSIT. If you guys don't know about this, F1, this is new in Mathematica 11.2. Really cool stuff. You can get data from the data repository. I'll make a video on this later. Keep an eye out for that. So yeah, that's really cool if you want to get some data, resource object, really cool stuff, new Mathematica 11. So let's get some data on digits, okay? And I forgot to put a semicolon. Let's abort that and semicolon it. Again, semicolons that make it much faster, so don't ever forget to do that. And let's just look at a sample of this data. It's calling from the internet, so if you don't have internet, this won't work. But let's just look at a sample of the data after that runs. And let me just put out the code here. I'll explain what it does in a couple minutes. Right, so here's the sample, right? So basically, resource data, resource object, MNSIT, basically gives us a bunch of handwritten numbers. So what we're going to do with this is I'll just show you, right? So what I did here is I flattened the image data. I just took a random sample, right? So to randomize the numbers. And then I took the image data, which if you don't know, takes the pixel values, or in this case, yeah, the pixel values. And then I just flattened it into one big list. So this 5 becomes just of rows of zeros and ones in this case. Not zeros and ones, my bad. A row of numbers, and a list of numbers basically, and I assign it to digits. Let's run that. Beautiful. Okay. And then again, like we did classify before, I'm gonna have a training set and a test set. So let's look at the length of digits here. Length of digits. 10,000. Again, you want to have a good 90% is pretty good. I personally like to go with 80%. So let's try that. From that, and then let's see if this works here. Sorry about that. Let's see if this works. So we're doing a feature extraction on the training set, right? So again, never put the test set in the training set. On the training set, using this option, missing imputed. Run that. Again, if you don't know what this is, look at the documentation. I'm not going to go into it. This is just a basic course. But yeah, so here we got a numerical vector, right? So it realized that this is a numerical vector, that the data we gave in was a numerical vector. And again, it gives us a bunch more. Look at the documentation if you want to know more. Now I'm going to call a function called vector. Not function, a variable. And that's basically doing a random choice, which you can see here. Chooses at random from a list, right? So it's choosing at random from this list, choosing a random number, a random set. Oh, not bad. There we go. And I'm going to create that into an image real fast. And then I will, that's a function right here, 2 images of function. And then next thing here, vector emission. So what I'm going to do here is I'm going to create something that looks like this. Basically what I did is I cut out all these points, right? So I made it's an image, and I partitioned it into different, like 28 different things. And I basically cut out all the rows from 309 to 364. And this is just 2 image, and then replace from vector missing. I'm going to replace the missing with 0.5, right? So we can see it, right? So 0.5 is this gray color, and it's just to show, and we can see it, right? So what we can do now is, given our feature extraction function, right, what we found up here, we can simulate and we can fill in this blank. Boom, just like that, right? We didn't have to do anything. This feature extraction, given these 80,000 points, 8,000 points, it was able to fill in this blank. That is absolutely crazy. and that Mathematica can do something that simple in just a couple of lines of code, right? In any other language, you would have to write lines and lines and lines of code. Mathematica, that easy. Mathematica 11, that's the power. And let me just show you all this to see how close it really was. Boom, boom. Look at that, right? This is the original. This is without the bar, and this is with created with the feature extract. How close is that? So yeah, you can do a lot of stuff with feature extract, especially with the images. You can mash images up, and you can fill in the missing parts of an image, right? That's very cool, especially with historical documents and all that stuff. Fill in missing parts. So let's just look in. One last thing I want to show you today is built-in classifiers. So this will be really fast right here. Classify. You can classify. We saw before part 1. If you haven't seen it, go to part 1 in the links below. But classify. You can call the option language, and you can put something in a different language, and it will automatically tell you which language it is in. This, as you can tell, is all French, and it gives us out French. And it has some other really cool things too. So Mathematica 11 has a new thing called Facebook topic. It's another option for classify, and what it does, it gives us the topic it thinks this is, right? So let me take out this top probabilities real fast, and it's gonna load from the internet again. If you don't have internet, see, it says it's music, right? This is a really complicated sentence, but it was able to give in a bunch of data from Facebook topic, right? So like almost a lot of data that Mathematica had to put in just to create this. It was able to classify this as music. Let's look at top probabilities, see what else was there. Top probabilities, my bad, too many commas. See, we have music first, personal mood, personal mood, right? Love them. Pets and animals, I think carrot might have gone in there. Food and drink, obviously carrot, and leisure, play, love, eat, right? Music, obviously play piano, had a big part of this. So just Mathematica is able to do all this really fast. So, like I've said at the end of both of my other videos, which you can see in the links below, how many times am I going to say that? But as you can see, Mathematica can do some really incredible things in just a couple lines of code, right? I am playing around with this stuff right now. You should do that too. And tell me, please tell me. Go to my page, leave some comments. Please tell me if you find anything really interesting, right? I would love to know. And this is really interesting stuff. Mathematica 11 came out, what, 4 days ago. So really look into it and see what you can do, right? Have fun playing with Mathematica. Thank you, and remember to subscribe, like the video. Please like the video, it really means a lot to me. So subscribe, and again, check out my other videos, right? There's videos coming out every 2 days nowadays, and just check them out. Cool. Have fun with Mathematica, and see you in it. Machine Learning Made Easy with Mathematica Part 4.